Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is the database design concepts, and the same chapter, that is chapter number 7, that is the ER model. So in the last class we have discussed about the ER model, that is what is the ER model, how to represent the ER model, that is what is the entity relationship model, or we can say what is the ER model, that is the entity relationship model that is used in the ER diagram, that is the ER model. So let's start with the previous class session, what we have covered in the last class, then move to the today's topic, that is the today's class topic. That is what are the various views, what are the various constraints that is available in the ER model, right? So let's start with the previous class session. So ER model was developed to facilitate database design by allowing the specification of an enterprise schema. That is, whatever we use, whatever we apply, that will be applied by the database schema, that will be applied by the enterprise schema that represents the overall logical design of the database. So whenever I want to decide, or whenever I want that facilitate the database design, or by allow the specification of database schema or enterprise schema that represents the overall structure, overall logical structure of a database, that is known as the ER model. The ER model is very useful in mapping the meanings and interaction of the real world scenarios, or it is used in the meanings, what are the meanings and interaction of the real world scenario, that is how to deal with the various entity, and what are the relationship between the various entities that we have discussed in the last class. So the ER model employs three basic concepts. What are the three basic concepts? One is the entity sets, then relationship sets, and the attributes, which we study first. So what are the three parts that is available in the ER model? That is the entity sets, relationship sets, and the attributes. The ER model has been associated with diagrammatical representation. That is, the ER model is represented with the diagrammatical representation that we discuss in this chapter. That is the ER diagrams. Then we have discussed about the entity set. So whenever I combine multiple entities, that is a group of the entities, that is known as the entity set. So entity is a thing or object in the real world scenario that is differentiable from other objects. For example, every person in a university is an entity. So if I want to represent the various persons in a university, that is on nothing but the entity. And entity has a set of properties and the values for other set of properties that may uniquely identifying an entity. So if I want to identifying the entity, and if there are various properties that is available for the entity, that is used for uniquely identifying the entity. For example, a person may have person ID property whose values uniquely identify that person. So if I want to identify that person, that will be identified by using the person ID, that is a entity, and that is a primary key that is also available. In the same way, entity set is a set of the entities of the same type that share same properties, or that share same properties. So what is the entity set? That is a set of the entities of the same type that share the same properties of the attribute. Suppose my name is I have a properties, I have an attribute, that is a name, age, roll number. You have properties, that is a name, age, roll number. So you and me are both the entities of the same type. So we can, or your value and my value will be represented in the entity set, in the group of the entity, that is the entity set, with the use of the different types, with the use of the different properties. So we have discussed what are the entity sets and how to represent them in the entity sets, or what are the various model that is used in the entity set. And we have also discussed that is every entity is represented by a set of attributes. So there is a group of attributes also, set of attributes also, and these are the properties that is processed by each member of an entity set. And each entry has a value for each of its attribute, that is every entity has some value for the attributes, like name, age, roll number, that is the attribute, or that is the value for the attributes. For example, a particular instructor entity may have the value 12121 for the ID, the value MU for the name, and the value finance for the department name, and the value 90,000 for the salary. So these are the various we can say the value that is available for the various attributes of the entity. The ID attribute is also used to identifying instructors uniquely. So if I want to uniquely identifying the instructor that is instructed by the, or that is defined by the instructor ID, that is a primary key, that is a unique key for the instructor. These are the example that we have discussed. This is the instructor table, this is the student table. Then we also discuss about the relationship sets. In the same way, there is a group of entities, there is a group of attributes. In the same way, there is a group of relationship also. So, what is the relationship between two entities that will be represented by the various relationship type, by various relationship, we can say the set. So that is a relationship set is nothing but a container, or we can say the group that combines, or it is a set of the relationships of the same type. That is a, if the relationship is of same type, that is a one to one or one to many, that is represented by the relationship set. Formally, it is a mathematical relation on the n is greater than equals to 2. That is the entity set, and if E1, E2, En are the entity sets, then the relationship is defined. This is a relationship that is defined. Right. And the relationship may also have the attributes known as the descriptive attributes. Any relationship may have also the attributes, may also the feature that is available, that is known as the descriptive attributes. Consider a relationship set advisor with entity set instructor and the student. So this is the example that we have discussed, that is how are the various entities, or what are the various descriptive attribute that is used with the relationship. A relationship instance in a given relationship is used to identifying uniquely with the from the participating entities. Then we will discuss about this one also, that is what is the relationship, that is a binary relationship, that is a one-to-one relationship. Then next is the attribute, that is what is the attribute that is available, or what is the meaning of the attribute. So attribute can also be known as the domain, value set, or we can say the permitted value. So for each attribute there is a set of permitted values that is available, that is known as the domain or the value set of that attribute. Domain means a group, or the value set means a grouping of the values of that attribute. The domain of attribute course ID must be or might be set of all text strings of the certain length. Similarly, the domain of the attribute semester, that is the domain of the attribute that is given, that is a semester, might be strings from the set. So these are the various semester that is available, that are the domains of the attribute semester. So these are the domain, we can say the group from the set. What are the set that is available? That is a fall, winter, spring, summer. So these are the four semester that is available, that is covered under the domain. Formally, an attribute of an entity set is a function that maps from the entity set into the domain. So then we will discuss about the keys, that is the keys that is used to uniquely identifying the elements, or that is okay Larry. So that can be used to how to define the keys and how to measure them with the use of the various constraint, that is a key. So if I want to represent the entity attribute, that will be represented in the keys, and there's a primary key that uniquely identifies the keys, that is what are the various identifying keys or unique identifying keys that is available in the keys, right? Then we will discuss how to represent the key, what is the usage of the primary key, what is the usage of the next primary key. So how many primary keys are available that describes an individual entity or relationship, that is we explained. Now next is how to remove the redundant attributes in the entity set. So what are the various criteria, that is how to remove them in the entity set, or what are the various, we can say, the example that is denoted in the entity sets. And then we will discuss these are the various entity set, or these are the various redundant data that is available. So apply them, or apply the rule of the primary key that is available in various design forms. Then we will discuss about the ER diagrams, that is the next topic, that is what is the ER diagram that is available, that is used. So ER diagram can express the overall logical design or overall logical structure of a database. So if I want to represent the overall logical schema, or we can say the overall logical structure of a database graphically, that will be represented by using the ER diagram. So ER diagrams can be used to represent the we can say that to represent the or express the logical structure or represent the logical structure graphically. So ER diagrams are simple and clear qualities that we will account in various parts of the ER model. Now, what is the basic structure of the ER model, or what are the various basic content that is available in the ER models? So basic structure that is given in this one, there is an instructor, there is a student. Student or instructor advises the student. Now these are the various links, like rectangle that is represent the entity, diamond, lines, dash line, double lines that we have discussed, and this is one of the important part. Then what are the various mapping cardinalities, that is the one to one, one to many, many to many, and many to one. Relationship, that is the project guide is related with the project student as well as the instructor. That is a ternary relationship. Then also discuss about the weak entity set, that is what is a weak entity set and how it is used. So if I want to represent, that is if the entity does not have the capabilities to work with, that is known as the weak entity set. So that is uniquely identifying the course, or that is uniquely identifying the entity, that is known as the weak entity set. So clearly section entities are related to the course entities. Suppose we create a relationship section course between entities, that is the section and the course. Then the notion of the weak entity set formula is about intuition, that is a weak entity set can be represented with the double lines or the double lines that is available, and there is also a strong entity set that is available, and this is the weak entity set, that is a section course is represented as a weak entity set. Then next is the weak ER diagram for the university enterprise. This is a diagram that we will discuss. That is what is the ER diagram that is available for the enterprise representation. That is how to represent the whole university example with the use of the ER diagrams. Now, next is the reduction to the relational schema. That is how to reduce the terms into a relational schema. That is today's topic that is discussed. So how to represent them and how to make them visible, or make them, we can say, what are the various relationships that is available in the relation schema. That is the next topic, that is today's topic. So reduction to the relational schema. So we can represent a database that conforms to the ER database schema by a collection of relational schemas. So we can represent a database, or we are able to represent a database that conforms to the ER database schema. That is, what are the database schema that is available by a collection of the relational or relation schemas for each entity set and for each relationship set. So there are entity sets, there are relationship sets that is available in the database design. There is a unique relationship, or there is a unique schema, a relationship schema, relation schema, to which we assign the name of the corresponding entity set or relationship set. That is a we can say the relationship set or the entity set. Both the ER model and the relational database model are abstract. So both the models are abstract, that is the ER model and the relational database model, that are abstract logical representation of real world scenarios. Because the two models employ similar design principles, we can convert an ER design into the relational design. So if the two models employ the similar design attributes that are represented in the form of the ER diagram or in the form of the relational design. So there are two methods, one is the ER design, one is the relational design. In this section, we describe how an ER schema can be represented by a relational schema. So how the ER diagram, or how we can represent the ER schema that can be represented by the relationship schema, and how constraints are arising from the ER design can be mapped to the constraint of the relation schema that is also available. Then the next part is how to represent the strong entity set with the simple attributes. That is how to represent them, or to how to represent the strong or entity set that is available, that does not depend on anyone, that has full capabilities with the simple attributes. This is example that is given. Let A be a strong entity set with only one descriptive attributes, that is A1, A2, AN. We represent this by using the schema known as the E with N distinct attribute. Every tuple that is used in a relation, or each tuple in a relation that will be used, that will correspond to the one entity set that will be available of the entity set E. So for the schema that is derived from another entity set or strong entity set, the primary key of the entity set serves as the primary key. So one can represent with the use of the primary key also, so that will be followed with the primary key, that is the primary key of the resulting schema. So in simple terms, when we want to represent the strong entity set with the simple attributes, with the relation schemas, with the we can say the resulting schema that is available, that is done or that is derived by using the simple attributes. An illustration, consider the entity set student of the ER diagram that is represented in the figure 7.15. Now this is the figure of 7.15 that will be represented. Note that the student ID that will be represented, that is used, that is the primary key of the entity set. So these are the various keys, or we can say that these are the various attributes. The student table contains three attributes. One is the ID, then name, then total credits. And ID is the primary key of the entity set. It is also known as the primary key of the relation schema. Continuing with our example for the ER model, all the strong entity set that is available except the time slot can have only one simple attribute. So there will be only one simple attribute that is available. The schemas that is derived from these strong entity sets. So what are the schemas that is available that is derived? There is a classroom, and there are three, we can say the three attribute that is given. One is a building, then room number, then capacity, then department, department name, building, budget, then course ID, title, credit, then instructor ID, name, salary, student ID, name, total credit. So these are the various, we can say the entity sets, that is a schema that is derived from these entity sets. As you can see, both the instructor and the student schemas are different from the schema that you have discussed in the previous chapters. We shall revise this issue shortly. Then next is the how to represent the strong entity set with the complex attributes. That is a representation of the strong entity set with the strong or with the complex attributes. So when a strong entity set has non-simple attributes, things are a bit more complex. We handle composite attributes by creating a separate attribute for each of the component attributes. We do not create a separate attribute for the composite attribute itself. So there is no representation of the composite attribute that is given, that will be represented by the strong entity set. So for the composite attribute name, the schema that is generated for instructor contains the attribute first name, middle name, last name. So there is no attribute of the schema for the name. Similarly, for the composite attribute address, the schema that is generated contains the attribute street, city, state, zip code, and that will be represented in the street number and the street name and the apartment name. So that is how to represent the strong entity set with the complex attributes. That is, if there are more than one complex attribute that is available, that is also used to represent the strong entity sets. Now, how to represent the weak entity sets? So if there is a weak entity set that depend on the other entities, that will be also be represented with the help of the weak entity set. So let A be a weak entity set with the attributes A1 till AM. Let B be the strong entity set on which the A depends. Let the primary key of B consist of the attributes B1, B2, Bn. So we represent the entity set A by the relation schema that is known as the A with one attribute for more each of member of the set. So what are the various member that is available? That is the A1, A2 till AM union B1, B2 till Bn. So for schema that is derived from a weak entity set that is available, the combination of the primary key of the strong entity set and the discrimination of the weak entity set so serves as the primary key of the schema. So this is a representation of the weak entity sets. There is a course ID, there is a section ID, there is a semester, there is a year. The primary key consists of the primary key of the entity set course along with the discriminator of the section, which is the section ID, semester and the year. The next is representation of the relationship set. So what are the various or how to represent the relationship sets with the help of the ER diagram. This is the method. This is the A1 till AM union B1 till Bn. So these are the various entity sets that is available. That is the A1, A2 till AM and B1, B2 till Bm or Bn. So these are the various relationships that will be used. So one to one, one to many, many to one. This turned out to be larger set of attributes that we need in the primary key. So what are the primary key that is used instead as follows. So for a primary key many to many relationship, the union of the primary key attributes from the participating entity sets becomes the primary key. And for a binary one-to-one relationship set, the primary key of the either entity set can be chosen as the primary key. The choice can be made arbitrarily. And for a binary many-to-one or one-to-many relationship sets, the primary key of the attribute entity set on the many sides of the relationship serves as the primary key. This is used as the primary key, or this is used as we can say the foreign key that is available, that is used in the many-to-many relationship or the binary different types of relationship that is available. So these are the various schema that is derived in the figure 7.15, that is a thesis. And then redundancy of schema, that is what are the various issues that will be used or that will be comes under the redundancy of the schema, that is what type of duplicate data, duplicate design the schema that is available in the database design. So a relationship set linking a strong entity or weak entity to the corresponding strong entity. So if I want to combine the weak entity set to the strong entity set, that will be represented with the help of the relationship set, and there will be redundancy of the schema, that there is a duplication of the schema that is also available. And these relationships are many to one and has no descriptive attribute. Furthermore, the primary key of a weak entity sets includes the primary key of the strong entity set. So whatever the primary key of the weak entity set, that will be represented by the, or that will be represented also as the primary key of the strong entity set. So in the ER diagram, the weak entity set section is dependent on the strong entity set via the relationship set section course. The primary key of section is course ID, section ID, semester, year, and the primary key of the course is course ID. Since section course has no descriptive attribute, the sec course schema has an attribute, that is the course ID, sec ID, semester, and the year. So what is the schema that is used for the entity set section, that includes the attribute course ID, section ID, semester, year, among the others. In general, the schema for the relationship set linking a weak entity into corresponding strong entity is redundant. That is the duplicate data and does not need to be present in a relational database design based upon the ER diagram. Now, next is the combination of the schemas. That is, what are the various combination, what are the various schemas that is available, that is a combination of schemas. So consider a many to one relationship set AB from entity set A to the entity set B. Using our relational schema construction algorithm outlined previously, we get three schemas, that is A, B and AB. Suppose the participation of A in the relationship is total. That is, every entity A in the entity set B must participate in the relationship AB. Then we can combine the schemas, that is the A and the AB, to form the single schema that is consisting of the union of the attribute of both the schemas, that is the A and the AB. So let us examine the various relationship that is available in the ER diagram. So one is the instruction or instructor department, that is the schemas instructor and the department corresponding to the entity set, that is the A and the B respectively. The schema instructor department can be combined with the instructor schema. The resulting instructor schema consists of the attributes like ID, name, department name, and the salary. And there is another one, that is the student department, that is also one part of the or one relation of the ER model. One is the course department, one is the section class. So these are the various attributes. So we can say that these are the various schemas that is available over, these are the various relationships that is available in the ER diagram. Now, next topic is entity relationship design issues. That is, what are the various design issues that is available in designing, or that is used, or that is come across while designing the ER diagram or ER model. So this is the entity relationship design issues. So the notion of entity set and the relationship set are not precise. So whatever the notion that is available with the relationship set and the entity set are not precise, and it is also possible to define a set of entities and relationship among them in a number of different ways. That is, what are the various entities and what are the various relationship that is used. That is, there is a relationship among the entities and the attributes, or the relationship that is defined in a number of different ways. In this section, we examine basic issues that is available or that is come across along the design of an ER database schema. That is, what are the very basic issues that is available, or that what are the basic issues in the design of an ER database schema. Section 7.10 covers overall or the design process in the further detail. That is, what are the design process that is available in the ER model. So in this we are covering the what are the ER design issue, or the what are the ER database design issues. That is the entity relationship design issues. So first part is use of entity sets versus attributes. So what's the usage of the entity set that is used with the attributes? So consider the entity set that is the instructor with the additional attribute that is a phone number. It can be easily be argued that a phone is an entity in its own right with the attributes for number and the location. The location may be the office or the home where the phone is located, with the mobile number or with the mobile phone perhaps represented by the value mobile. If we take off the care of the view, we do not add the attribute for number to the instructor. Rather, we can create the phone entity set with the attribute for number and the location. A relationship set instruction phone on the instructor phone denoting the association or association between the instructor and the phone that they have. This is the how to use the entity set with the versus attributes. The main difference then is that treating a phone as an entity better model as a condition where one may want to keep extra information about a phone, such as its location, type, what is the type, that is a mobile, iPhone, or the plain old phone, or all who shares the phone. Therefore, thus treating the phone as an entity is more general than treating it as an attribute. So treat the phone as an entity is more general, is more useful than treating it as an attribute, and is appropriate when its granularity may be useful. So this is the alternative for adding the phone to the instructor entity set. In contrast, it would not be appropriate to treat the attribute name of the instructor as an entity. It is difficult to argue that name is an entity in its own right place. Now, use of the entity set versus the relationship set. So this is also the, we can say, the issues. Sometimes we use the entity set in place of the or sometimes we use the entity set rather to use the relationship set. So this is the versus entity set versus relationship set. This is the registration, then section registration, student registration that is available. This is the student registration, that is the replacement of text by a registration and the two relationship sets. Both the approach of figure 7.15 and the 7.18 accurately represent the university information, but uses the term text are more compact and probably preferable. Then next is the binary versus n array relationship sets. That is the what is the we can say the next issue is what is the difference between the binary sets that is available and what is the relationship set that is available in the binary terms. That is what are the various issues that is available with the binary term. So relationship in the database design that is used with the binary type are often binary. Some relationships that appear to be non-binary, that is actuality, can be better represented by several binary relationships. So there are so many relationships, there are so many binary relationships that is also available, that is a binary versus relationship sets. Hello, hello, hello. So there is a binary relationship, there is a we can say the binary, and there is a relationship set that is a combination of the relationships, that is a binary relationship. So this is a binary versus the n array relationship sets. Now array that is relating the E and the A, then RG that is relating the E and the B. So this is the ternary relationship versus the three binary relationship. This is the A, B, R, C. This is the A, B, E, C. Consider the relationship that is a set project guide in the section 7.2.2 that is relating with the instructor, student and the project. That is how the various entities are related with each other. That is the instructor, that is the student, and this is the project. This is the date as an attribute of the student entity set. So this is the crick, this is the ID, then cats, then these are the ID, then Srinivasan, that is this is also ID. Then the placement of relationship attributes, that is next topic is next issue that is available, how to place or where to place the relationship attributes. That is there is a proper symbol, there is a margin, there is a gap, there is a diamond. That is how to represent or how to place the relationship attribute. That is whatever the attribute that is given, whatever the relationship that is given, that will be represented by what attribute or by what column name, that is a attribute name. Then the next topic is extended ER features. That is what are the various extended ER features that is available. That is the next topic. So although the basic ER concepts can model most database features, some aspects of database may be more aptly expressed by a certain extension to the basic ER model. So there are some extended ER features, extended ER diagram model also available. In this section, we discuss the extended ER features of specialization, generalization, higher and the lower level entity sets, attribute inheritance, and the aggregation. To help with the discussion, we shall use a slightly more elaborate database schema for the university. In particular, we shall model the various people within a university for defining an empty or entity set person with the attributes ID, name, and the address. So for the representing the ER feature, that is a expandable ER feature that is available, we use the term, we can say the entity that is used, that is a person, and there are various attributes in this, and that is a name, ID, and the address. So what is the name of the person, what is the name of ID of the person, what is the address of the person. Now first is 7.8.1 is specialization. That is what is the specialization, how it is used. The entity set may include the subgrouping of the entities that are differentiated or that are distinct in the same way from other entities in the set. For example, a subset of the entities within the entity set have attributes that are not shared by all the entities in the entity set. That is a specialization. As an example, the entity set person may be further classified as one of the following. So entity set person may be represented with one of the following, that is the employee and the student. As another example, suppose a university takes student into the two categories. One is a graduate, one is a postgraduate. Sorry, one is a graduate, one is a undergraduate. Graduate per student have an office assigned to them. Undergraduate are assigned to residential college. Each of them student types is described by a set of attributes that includes the attribute of the entity set student plus the additional attributes. The university could create two specialization of the student, that is name graduate and the undergraduates. We can also apply the specialization repeatedly to refine a design. For example, university employees may be further classified as of the following, that is the instructor, that is the security. Then next is the generalization, that is refining the initial entity set into the different levels of the subgroups that follows a top-down approach. That is from the beginning it moves down to the follows a top-down approach. The design process may also proceed in a bottom-up approach in which the multiple entity sets are synthesized into the higher level entity set on the basis of common features. So it is represented into various sets, various low level sets, various high level set that is available on the basis of the common features. So one is a top down approach, one is a bottom up approach that is available. The database designer may have first identifying, that is what the role of the database designer to identifying, that is the instructor entity set with the attribute instructor ID, instructor name, instructor salary and the rank. Then secretary entity set with the attributes secretary ID, secretary name, secretary salary and the hours per week. There are similarities among the instructor entity set and the secretary entity. This commonality, that is what is the common, that is represented by the generalization. High and the low level entity sets may also be designed by the terms superclasses and the subclasses. And the person that is defined is known as the person or the attribute name. Now next is the attribute inheritance. So whenever we use the properties of the low level and the high level entities, that is created by the generalization and the specialization. So whenever we use the specialization and the generalization, that is used to denote the high level and the low level entities, that is known as the attribute inheritance. The attributes of the high level entity sets are said to be inherited by the low level entity sets. So whatever the attribute that is available, that is represented in the low level or that can be inherited in the low level entity set. For example, student and employee inherits the attribute of the person. So whatever the student, whatever the employee, they inherit the properties of a, inherit the attributes of a person. Therefore, the student is described by its ID, name and address attribute, and additionally a total credit attributes. A low level entity set also inherits participation in the relationship sets in which its lower level entity sets participates. Like attribute inheritance, participation in inheritance applies through all tiers of the low level entity sets that is available. So whether a given portion of ER model was arrived by a specialization or generalization, the outcomes are these. One is a high level entity set, so there is a level that is available. So one is a high level entity sets, one is the low level entity sets. And figure 7.21 depicts a hierarchy of the entity sets that is available. So this is a single inheritance, there is a multiple inheritance that is known, and the resulting structure is known as the lattice. Now next is the constraints on the generalization, that is what are the various constraints, what are the various restrictions that is will be applied on the generalization. So to model an enterprise more accurately, so if I want to model the enterprise more accurately, the database designers may choose to place certain constraint that will be available on the particular generalization. One type of constraint involves determining which entities can be a member of a given low-level entity. That is, what are the various members or which entity can be a member of the given low-level entity. Such a membership can be any of the following. So such membership may be any of the following that is available. What are the various memberships? First is the condition defined. There is a every work or every processing is followed the condition. That is every processing is done on the basis of the condition satisfied. Then there is a user defined. So this is the one is a condition defined. Then that is defined by the user defined. Second type of constraint that is related to whether or not the entities may belong to more than one low level entity set within a single generalization. So within a single generalization, there are multiple entities that are not related to the more than one low level entity sets. The low level entity sets may be one of the following, that is a disjoint, then there is a overlapping. So disjoint means that is an entity can belong to not more than one low-level entity sets. That is a disjoint. Then there is overlapping, that is also available in the disjoint feature. Now next is the aggregation. That is aggregation means we cannot one of the limitations that is available of the ER model is that we cannot express the relationship among the relationships. So we cannot express the relationship within the another relationship. To illustrate the need for such constraint, consider the ternary relationship, that is a project guide that we have discussed. So suppose that instructor have a project ID project guide that is required to file a monthly evaluation. It appears that the relationship sets project guide and the evaluation for can be combined into one relationship or single into one single relationship set. The best way to model a situation is to one that describes an aggregation. So aggregation is an abstraction through which the relationships are treated as a high-level entities. That is, it is an abstraction that which through which the different relationships are treated, or different parts are treated as a high-level entities. That is, what are the various entities or how to represent that entities in a high-level entities. So it is an abstraction through which the relationship sets or the relationships are treated as a high-level entities. That is, the relationship are marked as a or treated as a high-level entities. What are the various high-level entities that is available for making the construct available? Now this is for the with the redundant relationship that is also available. Now next is how to reduction to the relation schema. That is, now we are in a position to represent how to reduce the relation schema or how to use the relation schema. So next is the reduction to the relationship schema that I will discuss after the break. So let's take a break right now, then move to this part, that is moves to the next topic, then moves to the next topic, or that moves to the next part, that is the reduction to the relation schema. So let's take a break right now. Topic is so come back from the break. Next topic is the reduction to the relation schemas, or what are the various reduction that is available in the relation schemas. That is a reduction to the relation schema that is available. So we are in a position now to describe how the extended ER features can be translated into the relation schemas, or how what are the various ER features that is available or that is translated into the relation schemas, right? So the first topic is representation of the generalization, that is how to represent them in the generalization part. So there are two different methods of designing a relation schema that is available for the ER model that includes the generalization. So there are two methods, there are two parts that will be used for designing the relation schemas that will be used for the ER models or ER diagrams that includes the generalization. So first part that is used, that is a create a schema for the high level entity sets. For each low-level entity sets, create a schema that includes an attribute for each of the attribute of that entity set plus one for each attribute of the primary key for the higher level entity sets. So first of all, creates a schema for the high level entity sets, create a schema for the low level entity set. So there are two schemas that is available. One is for the low level entity set, one is for the high level entity set that is available. So this is ER diagram with the aggregation that is used. So this is the instructor, this is the project, this is the student, this is the project guide, and this is the evaluation for the evaluation part. So the primary key attributes of the high level entity sets becomes primary set of the high level entity set as well as the low level entity sets. These can be seen underlined in the above example. This is the example that is used. This is a, we can say, the representation of the graphical representation, that is the instructor, there is a project, student, evaluation. In addition to this, we create a foreign key constraint on the lower level entities that is setting up or that is used with the primary key attribute that references the primary key of the relation that is created from the high level entity sets. So in the above example, the ID attribute of the employee would refer to the primary key of the person, and similarly for the student that is used. Now second part, that is the alternative representation that is also possible, that is used if the generalization is disjoint and the complete. So if the generalization that is available is the disjoint and there is a complete, that is if the no entity is a member of the two level entity set that is directly using the high level entity set that is available. So both these schemas have an ID, which is a primary key attribute of the high level entity set. Person has a primary key. Now this is a second method that is used, that is will be used as a overlapping generalization. That is there is a overlapping generalization that is used, and that is a generalization is made for the disjoint that will not complete. That is, if some person is neither an employee nor a student, then the extra schema that is available, person, ID, street, city, would be required to represent such people. So there are multiple people that will be represented with the help of the ID, with the help of the name, with the help of the street, with the help of the city that is available from this. So if we do so, the result is the first method that was presented. Now next is how to represent the aggregation. The aggregation will be represented by using the various terms, by using the evaluation method, by using the project guide. Now next is alternative notations for modeling the data. That is, what are the various alternative notation that is used for modeling the data. So a diagrammatical representation of a data model of an application is a very important part of designing a database schema. So if I want to represent the database model, if I want to represent the data model of an application, that is very important part in designing a database schema. So what is a database schema and how it will be represented in the ER model, that is a diagrammatical representation. So creation of a database schema requires not only data modeling experts but also the domain expert who know the requirement of the application. So there is a requirement of the database schema as well as there is a requirement of the domain expert that will know the requirement of the applications but may not be familiar with the data modeling. A number of alternative notations for the data modeling data have been proposed, of which ER model and the UML class diagrams. So remember these UML class diagrams that you had discussed or that we have done in the assignment part, that is of the C assignment part. There is no universal standard for the ER diagram notation. And there are different books for their ER diagrams. So the entity set is represented by a rectangle. This is the entity set, and this is the relationship set, that is the R. This is the identifying relationship set for a weak entity set, that is also R. There is a total participation that is available of the entity set in the relationship. There is a many-to-many relationship, that is a many-to-many relationship. This is one-to-one relationship. If the arrows are used, that is a one-to-one relationship. That is a role indicator, that is a role name that is used. Then there are the different disjoint generalization, that is the total disjoint generalization that is used. So there is a E1, there are two parts, E2 and the E3. That is these are the various symbols that is used in the ER model. And these are the various attributes like A1, A2, A21, A3, A4, 0. Then this is the primary key that is represented in we can say the underlined. Then these are the various attributes of the weak entity set, that is A1. Then this is the many to one relationship, that is there is one and the many to one. This is many, this is one. Then this is the cardinality units or limits that is used. Then this is a generalization or specialization. Now next is alternative ER notation, that is what are the various alternative ER notation that will be used. So we can represent the many to many representation with the star also. These are the various attributes that will be denoted by the oval sign. This is a double oval sign, and this is the derived, that is a dotted line. So this is the various notation, that is the alternative ER notation that is used. Now next is the UML, that is what are the UML diagrams or what is the use of the UML diagram. So the entity relationship diagrams helps model the data representation component of a software system. So ER model is also used for the data representation of a various component that will be used of a software system. Data representation, however, only one part of an overall forms only one part of an overall system design. So whenever we represent the data, that is the data representation that forms only one part of an overall system design. Other components includes model of user interaction with the system, specification of functional modules of the system, their interaction, etc. So what are the various modules that will be used? What are the various models that will be used? That is used for the user interaction. That is the specification of the functional modules and their interaction. The UML, that is a unified modeling language, is a standard developed, or it is a standard language that is developed under the various aspects of the OMG, that is the object management group. So this language, that is a UML language, is the standard that is used, that is developed for the, or that is developed under the OMG, that is the object management group, for creating specifications of various components of the software system. Now some of the parts of the UML are, so what are the various parts of the UML? So one is the class diagram. So one of the part of the UML is the class diagram. One is the use case diagram. One is the activity diagram, implementation diagram. So these are the various parts of the UML. One is the class diagram that is used, that is similar to the ER diagram, and they are just like a ER diagram, that is a class diagram. Then use case diagram. In this, the person is represented with the use case, that is the use case diagram shows the interaction between the users and the systems, in particular the steps that they perform. Then activity diagram, that depicts the flow of the task between various components, that is how the task will be flowed, or what are the various we can say the terms, or what are the various tasks that will be used between the various components of a system. Then implementation diagrams, that represents how, or what are the relationship between the system and their interconnection. So it depends on the, or it represents only the interconnection part, that is how they are implemented, what is the implementation issues, both at the hardware level as well as the software level. We do not attempt to provide detailed coverage of the different aspects of UML here. And in UML technology, relationships are referred to as association. So if in a UML diagram I want to explain the relationship, that is also known as the association, that is used, that we use for the relationship constraint for the consistency with the ER terminology. We represent binary relationship set that will be used for consistency with the ER terminology. We represent the binary relationship set in the UML just like drawing a line. So the line is drawn with the use of the ER sets or the ER model that will be used for the database modeling. So this is the ER diagram notation, that is the entity with the attributes, that is a single attribute, composite attribute, multivalued attribute, and the derived attribute that is available. Then there is a role, that is a role 1, role 2, that is a binary relationship. There is a relationship attribute, that is a denoted by the multiple, we can say, the roles that is used. Then there is a cardinality constraint that is also available. Then there is an array attribute that is also available in the ER model that is used. Then there is an array attribute, that is there is a one-to-many relationship, there is a one-to-many, we can say, the attribute that is available. Then this is the E1, E2, E3, there is a overlapping generalization, disjoint generalization, and this is the equivalent in the UML. This is the R1, E2, E1, and these are the various symbols, that is the UML class diagram that will be used. Now, what are the various other aspects of the database design? So these are the aspects that we have discussed. Now, what are the various other aspects that will be available or that will be a part of the database design? So our extensive discussion of the database or the schema design in this chapter may create the false impression that the schema design is the only component of a database design. So whenever I want to design the database, the schema design is one of the important element, is one of the important aspect of the database design. That is how to design the schema, or what are the various attributes that will be designed in the schema. That is also one of the part. So first part that is available, one aspect that is available is the data constraints and the relations, or the relation or relational database design. So what are the one of the constraint, that is one of the constraint is a check constraint that will be available. So there are the various constraints that will be available, like primary key constraint, foreign key constraint, check constraint, assertions, and the triggers that is available. That is a data constraints. That is a check constraint that will be available in the database design. Constraints serve several purposes. The most obvious one is the automation of the consistency preservation. So if I want to express the constraint in a SQL database language, the designer is able to ensure that the database system itself enforces the constraints. This is more reliable than relying on the each application program individually. It also provides a central location for the update of the constraint and the addition of the new ones. A further advantage that is using in stating the constraint is that certain constraints are particularly useful in designing the relational database schemas that will be used. The formal approach that we'll be using to the relational database schemas allows us to state in a precise manner when a given condition is true, when a given design is a good one, and to transform poor design into the better one. And next part is that is the next topic, that is the usage requirements, and that is also the aspect of the database design. So what are the usage requirement, or what are the requirement of the usage, or we can say the user requirements? A database system performance is a critical aspect of most enterprise information system. So if I'm talking about the database system performance, that is one of the important aspect of the most important or enterprise information system. Performance pertains not only to the efficient use of the computing and the storage hardware being used, but also the efficiency of the people that will interact with the system. That depends upon the database or data. So there are two main metrics for the performance. So there are two parts of the performance that will be used. That is the throughput and the response time. Throughput means the output. So what is the output for this one, and what is the response time? That is what is the response time for this one? So the throughput means the number of queries or updates that can be processed on average per unit of time. So that is what are the various queries, or what are the number of queries or the update that will be used or that can be processed on an average per unit of time. That is the throughput. Then next is the response time, that is the amount of time a single transaction takes from the start to the finish in either the average case or the worst case. So response time means the maximum time or the average time that is taken from the start to the end or start to the finish in either of the average case, in either of the worst case. That is a response time, that is a time that is taken for a single transaction to take or to start from the finish. And throughput means the number of queries or update that can be processed on an average period of time. So these are the two requirements, or these are the two metrics that is used for the checking the performance of the system, checking the performance of the database. And what are the various queries that is available, like data manipulation language, data definition language? These are the various queries of this one. Like SQL where clause, that is likely to be disappear or likely to appear. Another aspect of queries that affects the choice of indices is the relative mix of update and the read operations. Now the next aspect that is used is the authorization requirement. So what are the various authorization requirement? That is also the important phase that is used in this one. So authorization constraint also affects the design of the database as well as SQL, because SQL allows access to be granted to the user on the basis of the components of the logical design of the database. That is the authorization constraint, that is the authorization requirement. A relation schema may need to be decomposed into two or more schemas to facilitate the granting of access right in the SQL. So what are the various granting rights, or what are the various issues that is available with the granting or that is available for the requirement authorization requirement. So authorization constraint also affects the design of the database as well as phase, because the SQL allows access to be granted to the users. Now next is the data flow and the workflow. Data flow means the flow of the data from which by which the data will be represented from one form to the another form. That is what data flow. Or the workflow means from where the data will be gone from the one place to the another place. That is a workflow. That refers to the combination of the data and the task that is involved in the processes like those of the previous or preceding examples. Workflows interact with the database system as they move among the users, and users perform their task on the workflow. Now what are the various what else issues or the other issues in the database design? So database design is usually not a one-time activity. The needs of an organization evolve continually, and the data that it needs to store also involve the correspondingly. So it is very important to differentiate the various schemas, various diagrams, various role model that will be used in the database schemas. And finally, it is worth noting that a database design is a human-oriented activity in two senses. So why it is used as a, or why it is approached as a human-oriented activity? Because it is available, or it is we can say that it is used in the two senses. First one is the end users of the program are the people, and the database designer that needs to interact with the experts in the application domain. So there are two parts. One is the end users who uses the system. One is the database designer who designs the system. All of the people involved with the data have needs and the preferences that should be taken into account in order for a database design. So every people that is involved in the database must be taken care of or must be taken care of the account in order for the database design and deployment to succeed within the enterprise that is available. Now next is the summary. That is a summary of this chapter. That is the database design mainly involves the design of the database schema. The ER data model is a widely used data model for the database design. So this is the first step. So we are winding up with the chapter. This is a summary that is available. So first part says the database design mainly concern or involves the design of the database schema. The ER model is widely used data model for the database design. That is the ER model. This is one of the important model that is used for the database design. Then it provides a convenient graphical representation to view the data. So it also gives a graphical representation to view the data relationship and their constraints. Then next point is the ER model is intended primarily for the database design processes. So if I want to design the database, the ER model is built only for the database design processes. It was developed to facilitate database design by allowing the specification of an entity or enterprise schema. Such a schema represents the overall logical design or logical structure of the database. This overall structure can be represented with the help of the ER model or ER diagram. So if I want to express, if I want to represent, so if I want to define the structure of a ER model in a graphical format, that will be represented with the help of the ER model. Next point says an entity is an object that exists in two quantities, that exist in two varieties, that exist in the real world, and it is differentiable from other objects. We express that distinction by associating with each entity a set of attributes that describes the object. Now what is the relationship? That is an association among the various entity. And the relationship set means a combination of various relationships of the same types. Then next, the term super key, candidate key, primary key, that also apply to the entity and the relationship set as they do for the related or the relation schemas. Then mapping cardinalities, that expresses the number of entities to which the other entity can be associated by a relationship set. That is a mapping cardinality. Then the entity set that does not have a sufficient attribute to form a primary key is termed as the weak entity set. That is entity that does not have a sufficient attributes, or we can say that does not have a sufficient feature that will be available to form a or to represent as a strong entity, that will be known as the weak entity sets. An entity set that has a primary key is termed as a strong entity set. Next point says the various features of the ER model that also offer the database design and numericals or choices that is available in the ER model. That is the best way to represent the enterprise being modeled. The concepts and the object are in some cases represented by the entities, relationship, or the attributes. Next, a database design that is specified by an ER model can also be represented by a collection of relation schemas. So there are multiple relation schemas that is also available for the ER diagrams. Then next is the specialization and the generalization that defines a containment relationship between a higher level entity set and one or more low level entity set. That is there are two terms, that is the specialization and the generalization, that is related with the or that makes a comparison between the high level entity sets and the low level entity sets. Specialization is a result of taking a subset of a high level entity set to form a low level entity set. And generalization is a result of taking the union of two disjoint to produce a high level entity set. Then aggregation, that is an abstraction in which the relationship sets are defined or treated as a high level entity set. Then UML, that is a modeling language or popular modeling language that are usually or widely used for modeling the classes as well as for the general purpose data modeling. And these are the various review terms. These are the various review part that will be available for the this chapter, that will be used in this chapter. That is a ER data model, participation, the null values, derived attribute, degree, ER mapping or mapping constraint, UML class diagram that will be used. Then these are the various questions about this chapter. These are the various diagrammatical representations. These are the various exercises. Now, next is chapter number 8, that is a relational database design. So this chapter is based on the design. So the next chapter is what are the or what is the usage or what is the meaning of the relational database design. That is the next part. That is first of all, there are features of that and what are the various schemas that is available, what are the various alternative, use the smaller schema, use the larger schema. That is a relational database design. So this chapter I am going to cover in the or start in the next class, that is in the tomorrow's class. So that's all for today's session, because there is no time left for starting a new chapter. So that's all for today's session. Thank you so much everyone for listening me. And if there is any doubt, any confusion, you can ask the doubts from me. So that's all for today's session. We will taking your next topic. I'm taking your next topic in the next class, that is in tomorrow's class. That is a relational database design. So that's all for today's session. Thank you so much everyone for listening me. Bye bye.